Solving the international recruiting case. Okay. Getting started with this case, the first two facts are the fact that a third of the students used to be international students and now it's dropped to 5%. These aren't facts that are really used in the case, but we can document them nevertheless. So, historical percentage, international was 33%, current percentage, international 5%. Now she's going to have a team of 5 people, so team size is 5, and she's going to 5 countries, and they're going to one city in each country. So we can just say destinations is 5. The base application fee is $50. The base application quantity is 400 applications per city or per destination. The delta fee is saying for every $5 she reduces the application fee, so we'll make it -5. The number of applications will drop by 4. So the delta quantity is -4. Now, some of you thought this was a mistake. Some of you weren't paying attention and you just assumed that they're always the opposite. They were supposed to be the same, and it affects how you deal with the rest of the case. But if this is the only thing that you had wrong, it was probably still worth a 90. It means you didn't read the problem carefully, but I'm not going to take a lot off of it as long as the model was right. Because if the model is right and you have it documented here, someone could look at it and see that you have a 4 there instead of a -4, easily change it to a -4, and everything else in the model will change. The cost for air travel is $28,000. The accommodations, the hotel is $400 per night per person. And this is a 2-night stay per city. Nights per city is 2. And so we have to build a model based on this. And so let's get started. So the thing that she has to, the thing that she has to figure out is what will the fee be. So the fee is a decision that Anne-Marie is going to have to make. All of these things are facts. So I will code them green. I haven't gotten to any assumptions yet. And the first thing is my quantity. My quantity, I'll do it as one big equation here. So assuming that my fee stays the same, let's say that my fee is $50. My quantity is going to be equal to my new quantity minus, my new fee minus my base fee divided by my delta fee times my delta quantity plus my base quantity. So at $50 it's 500, which makes sense. If I reduce my fee by $5 to 45, my quantity also went down by 4, which is correct. If it goes from 50, it goes up by 5 to 55, my quantity should turn to 404, which it does. That's also correct, and so we're good. Now, so the revenue, or the total application fees, so to speak, is equal to my fee times my application quantity, which is $22,000 at this quantity. Now, there's no cost of goods sold here. We could assume a cost of goods sold, the cost of photocopying the application, so each application will cost an extra 6 cents, or even if you made it $1 to run all the copies, it still isn't an appreciable part of the fee. And so basically we're in a situation that as the fee goes up, the quantity goes up, the higher the fee, the higher revenue. But let's get into the rest of it. The expenses, we have air travel, which is just a direct reference. For those of you who just put the $28,000 in there directly instead of making a reference to the fact, I'm going to take a couple of points off of that. When it comes to the model part, there are no numbers directly in our model. All of our numbers that we're typing in ourselves are going to be in color-coded areas. That's something I'm going to have to be adamant about. So we have air travel, and the other thing was the hotel. So the hotel is equal to the amount of the hotel cost times the number of people times the number of destinations times the number of nights per city. So the total cost for accommodations was $20,000, and she doesn't have any other expenses. So total expenses is equal to these two added together, or you could use sum, either way, so that my gross profit, so to speak, is equal to my revenue minus my total expenses. Now, if I was going to raise this to a point so that I was just breaking even, then I could go to my tools, go to solver, and I could set my objective gross profit to the value of 0 by changing this cell, and I could run it evolutionary and hit solve. And it didn't do anything. All right, let's solve it by hand. 100, no. 105, getting there. 110, okay. 107, 108. So somewhere between 107 and 108 gives us the lowest fee that we could charge and still break even on the trip. And with that, we would have a quantity. I could actually use floor on this because I can't have a fraction of an application. 107, 108. So 108 is the lowest fee that I could charge and still account for all of my costs. And my quantity ends up being 406 applications per city. So does anything there strike you as wrong? Okay, here's the thing. Your revenue is your fee times your quantity times your destinations, because it was at that price, that's how many applications they would get per city. So what I'm going to do is I'm going to set my quantity equal to all of this times destinations. So overall, I'd have 2,200 applications, or I could just book it into my revenue. So this is my quantity per city, and for my quantity overall, it would be quantity times destinations, which gives us 2,230, and revenue, which is equal to our fee times our quantity per city, 240,000. And so if we wanted to find the lowest fee that we could charge so that we were breaking even, we can see that at $50 even we're making money. At $20, 30, 25, 26. So at $26 per application, that is the lowest amount that we could charge and still have the trip break even. But at that price, our quantity is only 1,900. At 200, the quantity goes up even higher. The way that this is, it's a non-elastic price. So in order to answer the bonus question properly, what you needed to note was that the higher the fee, the higher the quantity. So there is no optimal fee, or the optimal fee is infinity. That completes the solution for this problem.